Welcome to this introductory guide on Git Worktrees. In this video, we'll explore how Git Worktrees can help you work on multiple branches simultaneously. We will explain all the concepts from scratch so you can follow along even if you are new to Git. So, what exactly are Git Worktrees? Git Worktrees allow you to check out multiple branches from the same repository into different directories. Each worktree has its own working directory, which means you can work on several branches at the same time, without them interfering with each other. What are the benefits of using worktrees? Firstly, you no longer need to stash changes when you want to switch between different tasks. Secondly, you can work on multiple features or bug fixes in parallel, greatly improving your productivity. Thirdly, you can avoid the overhead of having multiple clones of the same repository, saving disk space and time. Let's compare the traditional Git workflow with the Worktrees workflow. In a traditional workflow, suppose you're working on feature A, but you need to quickly fix a bug. What do? First, you have to stash your changes. Second, you switch to the bug fix branch. Third, you fix the bug and commit your changes. Fourth, you switch back to your feature branch. Finally, you pop the stash to continue your work. This process is quite cumbersome. Now let's see how worktrees simplify this. With worktrees, if you're working on feature A in its own worktree, and you need to fix a bug, there's no need to stash anything. First, simply navigate to the bug fix worktree directory. Second, fix the bug and commit. Finally, navigate back to your feature worktree, and you can continue working without any interruption. Worktrees streamline your workflow, making it more efficient and less error-prone. Here are some basic Git worktree commands you should know. First, to add a worktree, use the command git worktree add path to directory branch name. This creates a new worktree for the specified branch in the given directory. Second, to list all worktrees associated with your repository, use the command git worktree list. This will show you each worktree's path and the branch it's linked to. Third, to remove a worktree when you're done with it, use the command git worktree remove path to directory. Remember to commit or stash your changes in the worktree before removing it, or use the force flag, which we will discuss later. Let's see how to create a new worktree with a practical example. First, to create a worktree for an existing branch, use the command git worktree at /feature-login feature/login. This command creates a new directory named feature-login in the parent directory. It then checks out the feature/login branch in that directory. You can now work on this branch independently. Second, to create a worktree with a new branch, use the command git worktree add-b feature/navbar main. This creates a new branch called feature/navbar and bases it on main. It then sets up the worktree in the /navbar directory. Now let's explore how to manage your worktrees effectively. First, the git worktree list command shows the path to each worktree, the commit hash for the head, and the branch name in brackets. This gives you an overview of all your active worktrees. Second, to remove worktrees, use the command git worktree remove /feature-login. This removes the worktree directory and its administrative files. If you have uncommitted changes, you can force the removal using the command git worktree remove --force/navbar. Keep in mind that removing a worktree does not delete the branch itself, only the worktree. Let's dive into some advanced worktree usage. First, you can lock a worktree to prevent it from being accidentally deleted or moved. To lock a worktree, use the command git worktree lock /feature-login reason =WIP. Don't touch. To unlock it, use git worktree unlock /feature-login. Locking is useful when you have work in progress that you don't want disturbed. Second, you can create detached head worktrees, which are worktrees at specific commits or tags. For example, git worktree add /old-version 78 of 53d creates a worktree at the specified commit. Similarly, git worktree add /v2.0 v2.0 creates a worktree for the v2.0 tag. This is useful for examining code at a specific point in history, testing older versions, or creating hotfixes for released versions. Let's walk through a practical workflow example. Imagine you're developing a feature while also needing to handle production issues. First, set up your main repository by cloning it and navigating into the directory. Second, create a feature worktree using the command git worktree add-b feature/auth main. Third, navigate to the feature worktree and start development. Now, suppose a production bug is reported. Fourth, create a hotfix worktree from the production branch using the command git worktree add-b hotfix/login/hotfix production. Fifth, navigate to the hotfix worktree, fix the bug, and commit the changes. Sixth, return to your feature work by simply navigating back to your feature worktree and continue where you left off. Let's recap some best practices and summarize what we've learned. Use a consistent naming convention for your worktree directories. Keep worktrees in a parent or sibling directory to your main repository. Always clean up worktrees when you're done with them. Use locks for worktrees with important uncommitted changes. Consider using integrated development environment workspace features to manage multiple worktrees. And remember that Git hooks apply to all worktrees. To summarize, Git Worktrees boost productivity by eliminating context switching overhead. They enable parallel development, allowing you to work on multiple tasks simultaneously. They promote resource efficiency by sharing Git objects, saving disk space. They're ideal for code reviews, hotfixes, and maintaining multiple project versions. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.